Excuse me, Captain. I know this may sound silly, but can you fly?
Chapter 3, problem number 54. The captain of a plane wishes to proceed due west. The cruising speed of the plane is 245 meters per second relative to the air. A weather report indicates that a 38 meter per second wind is blowing from the south to the north. In what direction, measured with respect to due west, should the pilot head the plane relative to the air? So the airplane itself has an airspeed of 245 meters per second, and the pilot wants to go due west, but the problem is that there's a wind blowing north at 38 meters per second. So if the pilot ignores the wind, okay, the plane will do that and miss going west toward the airport. The pilot wants to go west, so I'm going to put 180 degrees along with the velocity of the plane relative to the ground, and the pilot wants to know at what angle he should direct the plane relative to west. Now we don't know the speed of the plane relative to the ground. That's called ground speed. We know the direction of the wind. We know the airspeed. We don't know what direction the plane should head. Okay, so we're going to put these velocities together. And before I do that, I want to change W to A, because even though they tell us that the wind is blowing, I'm going to say that it's the air moving rather than the wind moving. So I'm going to change that to A. And then you can see that if you take this plus this, VPA plus VAG, right, you have A here next to each other. That's equal to VPG. Okay. Now what I'm going to do is draw a vector diagram for this one. So I'm going to first draw an arrow for the wind, because I know that. So here it is. Let's say this represents the wind. Let me put it lower, or over here. Okay, so here's the wind. So this is VAG. Now, if I add to that VPA, so I am going to let this ruler represent the velocity of the plane relative to the air. And what I did is I put a P on this end and an A on that end. And I know that I have to put the A of the velocity vector for the plane onto the A for the velocity vector for the air. And I know that when I add these two vectors together, I should get a resultant vector VPG, which is west. So I'm going to draw an arrow directed west. So this arrow here represents VPA. This arrow here represents VPG. And the pilot wants to know what angle he needs to direct his plane relative to west. So we need to find this angle. So if you look at the triangle here, this angle is equal to that angle, alternate interior angles. If I take the sine of this angle, theta, that should be equal to the side opposite, which is in this case VAG, divided by the hypotenuse, which is VPA. So that the angle then is the arc sine of VAG over VPA, or the arc sine of 38 meters per second over 245 meters per second. And I'm getting about 8.9 degrees. And that would be south of west. Now, suppose we wanted to know the ground speed. Well, to get the ground speed, which would be the magnitude of the velocity of the plane relative to the ground, we would use the Pythagorean Theorem. And we could write that VPA squared is equal to VPG squared plus VAG squared. And then we would solve that for VPG. So VPG be the square root of VPA squared plus VAG squared.